Okay, we're starting to get into the meat of Unit 3 right now, and what we're looking at is something called bond energy. So what we're trying to do now is determine the heat in a reaction. So let's say that we had some type of fuel like methane, or it could be a pile of logs, whatever it is, and we need oxygen anytime we want a fire, and we burnt whatever the fuel is. We would make carbon dioxide and water in a combustion reaction. A lot of people always question, what do you mean you make water when you burn things? Hey, you make tons of water when you burn anything. The water just evaporates very quickly because it's at such a high temperature. If you ever took a cooled piece of glass and held it way up above a fire, lots of water would start to condensate on the bottom of that glass. Anyways, I diverge. This would give off lots of heat. So let's say negative 1,000 kilojoules per mole of fuel. I just made this number up. The negative means the reaction gives off heat. So there are ways that we can actually measure the heat that comes off a system. It's called a calorimeter. The other thing we can do is we can do various methods where we don't have to do an experiment to find the heat. And one of those things is bond energies. So in bond energies, you write down the reaction that you want. You make sure that it's balanced. So make sure there's equal numbers of everything on both sides. So for example, there's 2 hydrogens here, 2 here, 1 oxygen, 1 carbon, 2 hydrogens, 2 hydrogens. So this is balanced. The next thing you do is you draw the molecules. Now, here's where you're going to have to use your creativity a little bit. For example, carbon monoxide. How in the world would you ever know what that looked like? Because it's not a standard model. So what you have to do is you have to look up the structures. So I just looked up structure of carbon monoxide, and I found that it's carbon with 3 bonds to oxygen. Okay, so I would always double check by looking up structures. Structure of hydrogen gas, H's with 1 bond in it. Draw all of those. The next thing you do is you count all of the bonds. So here I have 2 OH bonds. I've got 1 there and I've got 1 there. In carbon solid, it's not bonded to anything, right? It's just carbon. CO, I looked up, it's got 1 C triple O bond, and H2 has 1 HH bond. Now, if you had a 2 out front here, or let's put a 3 out here front just so you can see. 3H2 would mean that you have 3 of these structures. So all you do is draw 1 and multiply by the number that's out front when you do it. Folks, what you're going to find when you go into U3A3 is that on the first page there's a table, and it's got all of the bond energies. So, for example, the bond energy of OH is 463, but you have 2 of those, so it's 2 times 463. The bond energy of C triple bond to O is 1076, and to HH it's 432. The whole formula here is to add up all the reactant bonds on one side, that's 926, add up all of the product bonds and subtract. So you're going to get 926 minus 1508 is negative 582 kilojoules per mole. In this formula, we're trying to find the heat. So delta H is the enthalpy or the heat of the reaction. This means sum of this sign. It means add up all your reactants. This means sum of add up all your products, just in case you're curious about that. This gives 958 kilojoules per mole of energy, which means that if you put your hand around this reaction when it went off, you could feel the heat coming off of it. Hints for success. Look up the structures. So look the images up if you're given a word equation. So if they said, for example, hydrochloric acid and you didn't know the formula, look up the structure. You'll see it's H with a single bond to Cl. Make sure the equation is balanced. If it's not balanced, this won't work. Once again, if they tell you a reaction, if they say methane plus oxygen makes water and carbon dioxide, you can look up balanced reaction of burning of methane. and you will get that balanced reaction if you're not good with balancing. Don't forget, a negative reaction means that heat is given off. In a question, if you're doing a quiz, which you will do at the end of this, if they say how much energy is given off by, let's say it's 3 moles, then all you do is look at your balanced reaction. If you have 1 mole of a substance and they're asking for 3, you just multiply your final answer by 3. Folks, I think that's everything you should need for doing bond energies. This is only 2 pages of activities, or of content, sorry. And then you have a quiz, U3A3, when you're done this.